There is a part on your outboard right now that costs about $8. You can replace it yourself in 15 minutes with one socket wrench. But if that part fails and nobody tells you, a Yamaha F150 lower unit replacement runs $3,500. A Mercury Verado runs $7,000 to $9,000, just for the part. It is called a sacrificial anode, and yours might already be gone. Here is what is happening underneath your motor right now. Your lower unit housing is aluminum, your propeller is stainless steel, and the salt water between them creates a battery. Electrons flow from the more reactive metal to the less reactive one, and the more reactive metal dissolves. On your outboard, the aluminum lower unit would be the one dissolving, except the sacrificial anode bolted to the housing is even more reactive. So the anode corrodes first. It takes the hit so your lower unit does not have to. Think of it like a bodyguard stepping in front of a bullet. But once that bodyguard is consumed, your aluminum lower unit housing becomes the next target. And salt water is relentless. It corrodes aluminum roughly 5 times faster than fresh water. In the warm waters along the Gulf Coast and South Florida, that rate nearly doubles again. There is also a nastier version called stray current corrosion, caused by faulty wiring on your boat or a neighboring boat leaking current into the marina water. Stray current corrosion runs at roughly 100 times normal speed. Marine technicians have documented brand new outdrives corroding to nothing in 3 to 4 days from a single bad shore power connection at a marina dock. A galvanic isolator installed on your shore power cord is the only real defense against that, and they run about $100 to $300 installed. Now, a corroded lower unit follows a predictable pattern that every boat owner should recognize. First, paint blistering on the sharp edges of the housing near the prop hub. Then white powdery aluminum oxide appearing around stainless steel fasteners. After that comes pitting, where small craters form in the aluminum around bolt holes and the skeg. In the worst cases, the aluminum goes spongy and crumbles. Pinholes develop through the gearcase wall, and your gear oil turns into a chocolate milkshake. That milky color means water has breached the housing. Every bit of that damage is permanent. You cannot reverse pitting on aluminum. Once it starts, your only options are rebuild or full replacement. So what does replacement cost when corrosion wins? A Yamaha F150 lower unit assembly runs about $3,500 through an authorized dealer. The Yamaha F300 pushes past $5,000, but Mercury is where it gets brutal. A Mercury 150 4-stroke lower unit costs $5,500 to $8,800. The Verado line pushes past $7,000 for the gearcase alone. Add marine dealership labor at $100 to $175 per hour. A lower unit swap takes 2 to 3 hours. The total bill lands between $4,000 and over $10,000 depending on brand and horsepower. Aftermarket. Lower units from companies like Sterndrive Engineering can cut the Yamaha cost roughly in half, and used units show up on eBay for $800 to $1,500. But for Mercury, your aftermarket options are limited and the prices barely budge, all because of a part that costs less than a drive through lunch. Here is where it gets frustrating. Replacing anodes is one of the simplest jobs on any outboard. Mercury Marine's own maintenance documentation calls it a great DIY task. One socket wrench, 8 or 10 mm, 15 minutes. But annual service at marine dealerships costs $400 to $900 per outboard. Twins on a center console run $1,200 to $1,800. One boat owner received a $1,700 quote for twin Yamaha F150 annual service, and fellow boaters on a popular forum told him straight up he was being overcharged. The bigger issue is not even the markup, it is the neglect. Multiple owners have documented taking their motors in for paid annual service, only to find out afterward that depleted anodes were never replaced. One Suzuki owner discovered internal pencil anodes that had not been checked in years of paid dealer maintenance. A marine technician reported finding a prop anode held in place by nothing more than friction, not even properly connected. Whether that neglect is intentional or careless, the cost to your wallet is identical. A $15 preventive part eliminates a repair that generates thousands in dealership revenue for parts and labor. You can draw your own conclusions about the incentive structure there. If this is saving you money, hit subscribe. I break down the mechanical stuff dealerships will not show you every week. Now let me walk you through the actual fix. Locate the trim tab anode on the anti-cavitation plate above your propeller. Remove the bolt, pull off the old anode, and look at it. If more than half the metal is gone, it needed replacing months ago. Put the new one on, tighten the bolt, done. One detail that trips people up. The trim tab anode doubles as a steering trim device. There is a hash mark stamped into the tab that needs to line up with its original position after you swap it. Install it crooked and your boat pulls to one side at cruising speed. Takes 2 seconds to check. For the internal pencil anodes hidden inside the power head cooling passages, those cost $3 to $12 each and require removing small access plugs. Still a 15-minute job if you know where to look on your specific motor. Now the brand-specific issues. Yamaha had a documented problem with the F225 models built between 2000 and 2004. A defective coating inside the dry exhaust tube caused internal corrosion from condensation. One San Diego owner paid over $31,000 to replace both engines at just 500 hours. Yamaha created repair kits but never issued a formal recall. Mercury has no single notorious corrosion defect, but they charge the most for replacement lower units in the outboard industry. Skip your anodes on a Verado, and you face the steepest repair cliff of any brand. Suzuki has a documented seizure problem where the shaft corrodes to the crankshaft without annual removal and greasing in salt water. One owner on a fishing forum estimated that repair at $6,000 to $8,000 after the seized shaft cracked his lower unit housing during extraction. Every brand uses different anode configurations and part numbers. There is no universal anode. Match the part to your exact motor model. And here is something that catches experienced boaters off guard. The correct anode material for most modern outboards is not zinc anymore. Yamaha, Mercury, and Honda have shifted to aluminum anodes as their factory standard. Aluminum provides a stronger protective voltage against aluminum castings, and it works across saltwater, freshwater, and brackish conditions. Using the wrong material can void your manufacturer warranty. If your zinc anode looks shiny and untouched after a full season in the water, that is not a good sign. That means the anode is not electrically active and your lower unit is sitting unprotected. So the checklist is simple. Check your anodes every 3 to 6 months if you boat in salt water. Replace at 50% depletion, not when they are completely gone. Confirm you are running the correct material for your specific outboard. And never assume your dealership handled it during annual service. Walk out to the boat and look for yourself.